There is a word that I hear very often these days in Armenia. In Armenian, it sounds like... Yeah, can you hear me now? Yeah, it's a word. A number of events in the Armenian techno. No, it's not connected with my voice, I think. Seems like it's okay now, or not? Great. So it's our second already engineering meetup at Yandex Hall, and also the fourth meetup by ACA at Yandex Hall in general. And I am happy that we are keeping the track, keeping the pace, and I think that now we can say that the impact of Yandex Hall and events on the Yandex Hall is quite tangible, because we are not limiting with meetups, we are not limiting with one-day events along with Yandex, and we are going to have a deep academic program with Yandex called Engineering Deep Dive. And today the first speaker also is the leader of the Engineering Deep Dive designed for professionals with certain level of experience in software engineering. And I want to invite to the stage Andranik Khandanyan, Java practice leader at Armenian Code Academy and leader of Engineering Deep Dive.
Thank you, Narek. Hey everyone, I'm Andranik, and today we are going to talk about the hype of system design and some missing pieces of system design resources which is provided in those resources. And for the beginning, I want to start with a question. Just raise your hand if you ever participated to a system design interview. Great. And who of you succeeded in that interview? Yeah, quite I expected a little bit more. And that's the numbers we saw here, raised hands who participated. It's something I saw while I was trying to validate and the relevancy of this topic. I was looking for some numbers, and I came up with this data from Google Trends. This is Armenian data about searches, about system design and software architecture. You see, from 2021, there is a spike lasting till today about system design, but also you can notice a red line there. It is a software architecture, and from this data, it seems that no one Googled software architecture in Armenia, but I'm sure some of us did that. And it is an interesting part about Armenia, but also worldwide, we can see kind of similar trends. And from December 2020, there is a huge spike in interest about system design. And it's in comparison with software architecture, there is a huge difference between those. Also, we can think that system design is not only about software, it is also can include systems overall, because systems are everywhere and probably related to hardware. But what we can say surely that from 2020 there is a spike, and this spike is related to another trend presented on the right side. It is a system design interview interest. So we can clearly say that from that point there is a huge interest in system design interview and system design resource. And while those resources are great resources to learn about system design, I came up with thoughts that those resources are not enough to learn and succeed in system design or even in interview. And I came up with this when some of my friends were preparing for system design interview, and they asked me about resources, about system design, and obviously I suggested the book System Design Interview, which is a great book by Alex Xu, and some courses about system design. And at that same period, we were just starting our product, so it was in system design and architecturing stage. And I was also involved in another project which had requirement to support million users per day, not in an hour, not in a second, but in a day, but it also very much challenging. And at that point it hit on me that the resources I suggested to a developer who are just starting to learn about system design can mislead and can narrow down the knowledge required for building systems from the scratch. And today I'm going to explore with you some aspects that I think is missing, and I will try to share some experience of mine and also provide some theoretical resources and knowledges which you can build, and in combination with system design topics you can probably be better in system design. So now let's try to understand what's the issue. And for this topic, when I was preparing this topic, I was searching about definition of system design, and I put a couple of them, but you can find a lot of them on the first page of the Google, and they almost say the same. System design is the process of defining the architecture, components, modules, interfaces, and data for a system to satisfy required requirements. And I highlighted architecture part because whenever you see a system design resource, you see its content is mostly built upon components, meaning load balancers, key value store, caching, and etc. Those are building blocks and very important part of our system. We surely can see the back of envelope estimation part, and we see some great examples of system design, and those are designing something, designing YouTube, designing Google, and etc. And there are a lot of valuable information in those resources. And we can say, but what's missing here? What's not correct? Well, because in this kind of resources you can see, for example, this resources addressing, for example, scalability issue, but what is scalability? They never define it, but addressing those. So today we are going to talk about these parts, and for the reference, I'm presenting I will provide a QR code for books which I present here in presentation, and the System Design Interview book is a great book. You can learn a lot of resources from there. There are a lot of valuable information, so definitely worth reading. But in order to become better in system design, I will suggest this kind of framework: software architecture fundamentals and the system design with its components. And also I added here a system thinking, which I am trying to advocate for some time, and I will talk about it later on. And for beginning, I want to start how I start doing a project whenever I need to do a system design. I start with Kruchten's 4+1 view model. Oh, it's not animated, but Kruchten's 4+1 view model is kind of technique to focus your attention to some perspective of your system. It consists of 4 views. The first one is a logical view, where you represent your models of your system. Those models you can call objects, classes, entities, etc., but I define those as models because sometimes worth adding there some system component. The second view is process view. The process view represents solutions, or I will say it this way, it focuses on non-functional parts of software. And the third one is development view. And in development view, you try to understand how your development team are going to work, which kind of skill set you want, how you will do project management and any other stuff related to development. And the last part from force, it's physical view. In this part, you add hardware which you need for your project. But in order to start, I always start with this +1, and it's scenarios. The scenarios describe how users and different types of users behave in your system. I also add some system components if needed, but mostly those will be kind of user navigates to search, user searches for something, and it brings some results. And from those scenarios, you can extract the models. Everything there, like you see user, that means you have a model user. And in this fashion, you also can extract some system components which you need to address. From this stage, the requirements can exactly point out to some functional behavior, but what can be hidden in requirements, those are sometimes called non-functional requirement, which is kind of vague explanation what is non-functional, because it's a functional software. And for that reason, there is a name for non-functional requirements, and it's oftentimes called quality attributes, or in some resources it can be called architectural characteristics. In every software architecture book, probably, you will see this part. And you will see a lot of quality attributes here. I didn't put quality attributes here to learn or to talk about them. Unfortunately, we can't go deep into this topic. It is very much theoretical and also will take a lot of time, and probably a lot of you are familiar with this. Rather, you can later on investigate this. But there are a lot of them. And while reading system design resources, you will face some of them, but never a framework of quality attributes. But quality attributes are much more important because a lot of things in software architecture are dependent on quality attributes and build upon quality attributes. And I want to bring an example from my career when the first time I tried quality attributes in practice. It was in 2015 when we were working on a project which was operating for the whole country, and it was a huge monolith. And as new features were coming, we realized that we probably should transform it to microservices, and we never did something like that before. But our team lead at that point was against that decision, and after long discussions, we wasn't able to come up to a solution, and we reached some kind of deadlock. And during one of the meetings, I brought just flip chart, drawn a couple of columns there, and put critical quality attributes there, which are critical for that system. And we started to brainstorm about advantages and disadvantages of each quality attribute. And with that approach, we not only convinced our team lead, but also other stakeholders as well, including customers, and because that was a significant decision, because they had to invest a lot of work on that and maybe hold that features for some time. But looking with this to these arguments about quality attributes and looking forward to the future, that was a right decision, because only that decision helped the product to be alive till today. And but at that point, I didn't know any technique, accepted technique to how to analyze quality attributes. But there is some. Also, this intended to be an animation, so please pay attention to the top part. The bottom part, I will present it a little bit later. There is a technique called risk storming. It consists of 3 parts: identification, consensus, and mitigation. During identification, we use the risk matrix on the left. We take each component of the service, like customer registration, catalog, order fulfillment, etc. We take each quality attribute separately and we try to estimate risk related to concrete quality attribute for concrete component. And we estimate it like this: how it is likely that this will happen. For example, if we have centralized database and a couple of services working with this centralized database, we try to estimate how risky it is. Likelihood of, so let's first try to estimate what will happen if this database goes down. It is critical because nothing will work from that point on. So the risk is high. At that point, we estimate overall impact. But while we are using highly available servers for database and database is maintainable, we see its likelihood is very low. So we assess the overall risky point to 3. So at that point, we don't need to address the issue. But from somewhere, if we see that the risk is high, we need to address them. So this identification phase, each team member evaluate the risk, and then during consensus part, team members try to have a consensus, obviously, and there can be unknowns, and every unknown you can point to highest risk, but as team works, they can share knowledge, they can share risks, and come to some conclusion. And also in this technique, it's not only estimated the current state, also the progress state of these risks, because currently if you work on performance, it's probably going to go down, and at some point it will not be under risk at all. And but what's the point of all of this is the critical mitigation point where team decides on architectural changes. At that point, if something needed to be changed in architecture, it's done. It's a lot cheaper than to build, fail, and then build again. And if your project or architecturing in a stage where you have already defined architecture, it is visually more appealing to address those risks directly into the diagram, and will be much easier to understand and address if you have this. For example, in this example, you see that MongoDB logging is not at risk at all, so it can be ignored. But on the other hand, you can see that Elastic Load Balancer is under risk and probably need to mitigate it and brainstorm again. And from this point, you can notice in practice that a lot of quality attributes are conflicting with each other. The most famous example of this is security and performance. Every time you add new layer for your security, it will probably affect performance in a bad way. It will degrade. And those examples are a lot. And what should you notice and take a note that while doing this analysis, you have to know that you can't choose every quality attribute. You have to choose some critical attributes for your product and be aware that those attributes can be conflicting with each other, and you have to make a trade-off. But trade-offs are not about quality attributes only. I have another examples related to this stage of design. Once we were discussing a new feature which should be added to our, again, monolith, and it was custom reporting tool which should access to all data and provide customizable experience for the users to create custom reports. And we were discussing two approaches. One, to apply this to a monolith, and the second, to distribute it and create separate service for reporting and create a reporting database and etc. We were looking into quality attributes, and we evaluated that the second solution with distributed approach is much better in terms of quality attributes, but we went on implementing the first one in a monolith because of time and budget constraints. And time and budget constraints are always playing significant role in those kind of decisions. Probably you will see this in your day-to-day life when you say, come up with some great suggestion to your manager and you say, hey, let's build this in this way, it's a great system, I made a great system design, we can do this like this, and they, unfortunately, we don't have time or budget, we have high priority features we should build, or bugs to fix, and this is kind of the same which happening to refactoring. And if considering that refactoring or this kind of changes need a week or couple of weeks or month of work, system design could affect years. When your customer wants the project for a year, you can't create a system which will be built in 2 years. So this is always a constraint. Also, every time you start a project and starting to think about system design, you also should think about team's skill set, because teams will build this software, and it's very critical how mature is team in that technology in this situation, and you should consider this before making any decision. About the topics which I told you can learn from Fundamentals of Software Architecture. This is a great book, I think, and if you are just new in learning system design or want to sharpen your skills with theory, you can definitely start with this book and combine with system design other books to have holistic knowledge about system design. One of my another favorites, it's called C4 diagrams, but I will suggest not looking to this as just a diagramming approach, because C4 is presenting software in 4 different levels. That's why it's called C4, because the first one is context, then containers, components, and code. This is approach of documenting your architecture. And also, why I like this approach, because if you are focusing on the context level, for example, your whole focus goes to context. And when you focus on containers, you focus only on containers. I will briefly explain what every level is. The first level is the higher level of abstraction. It defines your system as a single item on the diagram, and it presents how your whole system will interact with external services or users, or how users should interact with your system, or vice versa. The second level is kind of focus on your context. Like if you build a monolith, you probably here you will have represented your front-end application, back-end application, not the database, mobile applications if they exist for your system. And if you are building microservices on this level, you will decide which kind of services you are going to have and how those will interact with each other. And this is the level where you can decide, where you can make macro architecture decisions. For example, with which protocol your service is going to talk with each other. Is it going to be REST, or it's gRPC, or it is messaging, or something else? Or even you can decide languages and frameworks policy here, like can you build each service with different language and framework, or you are going to use, for example, Java and PostgreSQL for whole of your services. On the next level, it takes on the focus the concrete container, and it's called component. Like it can be one of your services or your backend, and you start to design it. And here also you can take macro and micro architecture decisions and define how your concrete component are going to interact with other components. And last level is code level, and if you have some critical aspects, critical areas of your software, you can design it on this level. Probably it will be class diagrams, state diagrams, some sequence diagrams, which we're familiar and we work day to day. And yes, that's it about C4. And again, I want to mention that this is not, for me, this is not only diagramming technique, but also it limits focus. So if you are concentrating on building concrete container or concrete component, you are not, you don't do shifts between other services or think about higher level of abstraction or even about code. Oh, and this is the last part, I think, which I think is missing from system design parts. You can, again, see a lot of information here, but I don't want you to be disturbed by this. It's just for encouragement. And those are architecture styles, general architecture styles defined not only theoretically, but there are a lot of resources defining how this should work. And in this slide, concretely, you can see some ratings about architectural styles. It's not done by me. It's some kind of accepted, but you, of course, can disagree. I also disagree with some points of here. But what's the point here and why I'm talking about this today? Because when you see and read system design books or resources, you see that they take some approach and go straight to microservices. But before going to that point, you have to decide, is it the best fit for you? And oftentimes it will not be the option between best solution and the worst solution. Probably you wouldn't have the best solution. Probably you will choose the least worst solution for that case. Also, what's not presented here, and unfortunately I forgot to put that link in presentation, is stream processing and batch processing, which can be considered as a separate patterns, but those are currently very trending and also need to learn about. And from about these approaches, stream processing, batch processing, or a lot of insights about how systems work, you can learn from designing data-intensive applications. This is a great book. If you have a couple of years of experience, definitely worth reading. And the last part. I'm done with parts which is missing in system design resources and what I suggest to learn with system design to build this holistic knowledge. But I'm kind of advocating this idea from time to time of thinking in systems. I wouldn't go deep into systems, how to build, but systems are always around us and almost everything can be considered as a system. And what's more important for us, for software developers, all of this is very much similar to what's going on in a software. And I think it's my personal opinion that software developers who have good system thinking skills have more chances to succeed in software design. And without going into details of this system dynamics, I want to just bring an example and exercise how you can improve this thinking, and that is something I was suggesting to my students. You can take everything from your surrounding. Like years ago, I was suggesting to take the coffee vendor machine and just think about its elements. What separate elements are there? What is the purpose and the function of each of them? How they interact with each other? And what will happen if some of them goes down, for example, and how you can change it. And this practice helps you to improve skills to decide on elements and components for the software as well and define their relationships, because, you know, if you do this in a bad way, you end up with high coupling and low cohesion. So this will surely help you building systems. And I guess that's it from my side. Thank you for participating. Hope it was useful. Thanks Yandex and AC for organizing. And we'll be happy to hear your questions. No questions? Thank you again. Next, Vahe will present Unexpected Java. Vahe, welcome.